Okay, this video is going to be a challenge, but we can get through it. Remember, if you have questions, don't hesitate to ask, okay? So make sure you guys are emailing me if you have questions. We could try to do this a little bit differently if necessary. This is called finding chord measures in circles, all right? So our objective very simply is to find the measurements of segments that involve chords in a circle. Now, what do I know a chord is? Well, a chord very simply is if I go from one side of the circle to the other. For example, this segment AB right here, this is a chord, all right? And we've already been studying one of the chords already that could exist, and that would be something that goes from a side to the other side, passing through the center. So remember this, we'll call this CD, okay? This is called a diameter, but it's also less or more generally known as a chord, all right? So AB here is a chord, CD here is also a chord, but it's a more specific chord known as a diameter, okay? Now, we have one statement that we have to focus on here. And then what they're going to do is with the pictures, they're going to try to kind of mess with us a little bit, okay? It says, if a diameter or a radius is perpendicular to a chord, then it bisects the chord. Now remember, bisect, we've talked about that numerous times this year. That means cut into two equal pieces. All right, so let's take this diameter, all right, in this first picture on the left, and I'm going to draw a chord that forms a perpendicular with the diameter. If this occurs, then I know that this piece is congruent to this piece. That diameter bisects the chord as long as it is perpendicular to the chord. Okay? So let's do the same thing over here for what if they give me a radius? Well, the radius idea also works. If I have a chord right here and I tell you that this is perpendicular, I know that this chord is also being bisected by that radius. All right? Now, what they're going to do from this idea right here is to start drawing a bunch of different segments in the circle. All right? Here's the one that I really want you guys paying attention to. So let's start with the radius part here. If I draw that segment right there, this is also another radius. Okay? So the line in blue and the line in green are both radius or radii. So sometimes what's going to happen is they're going to break this one that's perpendicular to a chord, they're going to break it up into pieces. Well, a few things kind of kick into mind here. It could be just simply a manipulation or getting you to see things that are going on. It could be that I have to use Pythagorean theorem because you notice there's a right triangle being formed. All right. And it could be different things that involve segments within a right triangle. Okay. If I come back over to the diameter example, remember that would also be the radius. And that radius is the same as this radius that we were bisecting the chord with. All right. So let's jump into some of these. And again, if you guys have questions, please ask, okay? Shoot me an email and we can talk through it. We could even do a video chat if you wanted to. All right, so I look at this picture. The first thing that jumps out at me is what they want me to find. There's X, all right? The first thing that I notice is X in this case is a radius. So to find X, all that I need is a radius. I look at what they give me, 18 right here. 18 is a radius. So very simply, by observation, I can tell you that X has to be 18. all radii in a circle must be the same measurement. All radii in one circle must be the same measurement. All right, so let's take a look at this picture. All right, first thing I observe is there's x. I notice that x is on a chord. Okay, now I also notice here that this little segment right here is perpendicular to this chord. Now we just learned a statement where we focused on a diameter or a radius. If they were perpendicular to a chord, then it bisects the chord. It's also going to hold true here. I know that this piece and this piece have to be congruent. Therefore, very simply, I can conclude by observation that x has to be equal to 11. All right, let's take a look at this one now. Ooh. Well, there's x. In this case, x is representing the entire diameter. Now, I don't want to jump right into and try to find the entire diameter. Why? Because I don't know anything about it. But I do know that if I can find a radius, I know that 2 times the radius would give me the diameter. So let's see what else they gave me here. They tell me that this piece over here is 15.3, which means this piece over to the right here is also 15.3. Why? Because that is perpendicular to the chord. The chord, therefore, is being bisected. I know that if I put this measurement and this measurement together, that gives me this entire segment right there. And that segment is known as a radius. So here's what I'm able to deduce. I know that the radius can be found by taking 12.9 plus 7.1, or I know that I have a radius of 20. But that doesn't find x for me. Remember, x was the diameter. So to find x, I'm going to take 2 times 20, or I find that x is equal to 40. So if you haven't figured it out yet, guys, it's a pretty simple statement that says if a chord has a perpendicular attached to it, it bisects the chord. And in a circle, we have chords, we have radii, we have diameter. A lot of this lesson is just about visualization. Okay? There's not a whole bunch of algebra yet. But now we're going to get into a little bit of algebra. All right? They want me to find x. Now I notice that x is just this segment right here. That segment is not a radius. That segment is not a chord. But I do know some information about this is part of the chord and this is the radius. 15 is the radius. And what that creates for me is this right triangle. And if I have this right triangle here, I know that this is 15, this is 12.7, and they want me to find x. So even though I'm dealing with a circle and I got all these lines going everywhere, that's all. That triangle is all I got to focus on. To find the measurement of x, I'm going to use Pythagorean theorem. Remember, Pythagorean theorem says c squared is equal to a squared plus b squared. So 15 squared is equal to x squared plus 12.7 squared. Or 225 is equal to x squared plus, I got to use a calculator here, 12.7 squared, 161.29. All right, I'm going to subtract that, 225 minus 161.29, and I get 63.71. So x squared is equal to 63.71, and therefore I know that x has to be the square root of 63.71. And what did my directions say way back up here? Round your answers to the nearest tenth if necessary. Here's a problem where we're going to need to round to the nearest tenth. I need to take the square root of this, and it says 7.98. So we're going to use that 8 to bump the 9 up, and I'm going to be able to conclude that x would be approximately 8.0. All right, let's try another one like this. All right, so in this problem, I see the perpendicular. I know this chord is being bisected, which tells me that this piece also has to be 11. I see a triangle, a right triangle in here. I'm trying to sketch it so that it'll match with what I see here. And I know this is 7.4, this is 11, and this is x. I'm going to, because it's a right triangle, I'm going to use Pythagorean theorem that says the hypotenuse squared, remember that's how we always start off, x squared is equal to 7.4 squared plus 11 squared. Or I'm going to use the calculator to help me here, 7.4 squared plus 11 squared equals 175.76. So I know that x would be the square root of that. And we're going to round that to the nearest tenth. Square root of 175.76 would be 13 point. That 2 has to become a 3 because of the 5. So 13.3. All right, let's try one. We got two more like this. All right, let's take a look at this one now. All right, so this little segment right here is what they're referring to 12.7. So I'm going to write that on there. I'm going to actually, because I know that segment's 12.7, I'm going to write it over here. They want me to find x, which is this little piece right here. All right. I know that that's a part of the radius, but it's not the whole radius. Well, I'm going to look and create something unique in this situation. I know that that 16.5 right here represents the radius. I know that in a circle, all radii must be congruent. I can draw a radius anywhere that I want in this circle. I'm going to choose to draw one like this, which means that I know that this side is 16.5. I'm going to find this piece, and I know that x plus y has to give me the measurement of a radius. All right, so what am I looking at here? I've got this right triangle. And on this right triangle, I know this is 12.7. I know this is 16.5. And I called that y. So the first thing I'm going to do is find y, okay, by using the Pythagorean theorem. And this would be 16.5 squared is equal to y squared plus 12.7 squared. 12.7 squared. All right, so 16.5 squared, that'd be 272.25. And that's equal to y squared plus 12.7 squared, 161.29. I'm going to subtract 161.29, so I've got 272, that got away from me, 272.25 minus 161.29, 110.96. So y squared is 110.96. So y would be the square root of that. And if I take that square root, I get that it's about 10.5. Now, that didn't find the measurement of x yet. Here's what I know. I know, like we said before, that x plus y is the same as 16.5. We just found y to be 10.5. So x plus 10.5 is 16.5. And if I subtract 10.5, I get x is equal to 6. All right, that one took a lot of work. I only asked a few of these questions at the end of your worksheet that are like these. But let's try one more like this. All right. So I'm going to look at this triangle right here. Okay. Notice I got to find that x. I'm going to call this piece y, and that piece is 15.9. So let me sketch this triangle just so we can see the right triangle clearly. All right. I know that this side is 15.9 because it is bisecting that chord since a perpendicular is being formed. I know that piece is y, which is a part of a radius. And I know that if this hypotenuse here has to be 19.2. All right, so I'm able to deduce that 19.2 squared is equal to y squared plus 15.9 squared. Square 19.2, I get 368.64. Square 15.9, I get 252.81. I'm going to subtract 252.81 from 368.64. And that gives me 115.83. Y squared is what was that? 115.83. And when I take the square root of that, I'm going to round it to the nearest tenth. And I get that it's approximately 10.8. All right. Now, back over here, I know that if I take x plus y, that creates a radius. So x plus y had to be the measurement of the radius, 19.2. I've just found y to be 10.8. So x plus 10.8 is equal to 19.2. And if I take 19.2 and subtract 10.8, I find that x is going to be about equal to 8.4. I hope this helps. Please let me know if you have any questions. We can try to set up a video chat if you want me to help you work through a few problems. Good luck.